Hello, let's do checkpoint 6.33. We have a vector field F and a particle that moves from 4, 4, 1, 1. And they want us to check to see if this line integral will be positive, negative, or 0. It'd be nice if we get some idea what the vector field looks like, but what I can say is that in the first quadrant, which is where the curve lives, the vector field looks like it's just going to be pointing outward, going in either positive x and or positive y direction. And if we have any path going from 4, 4 to 1, 1, we're going to be moving in the opposite direction of the vector field. And whether that's a straight line or any other line, I think it all sums up to an opposite direction from the vector field. So given that we're going to be taking the dot product of a tangent vector with any of these vectors that's coming from the vector field, all those are going to be obtuse angles. And so my guess here would be that it's going to be negative. Now we can double check by actually computing it, and the nice thing about this is that I don't think we need to do the line integral itself, which probably wouldn't be so bad, but since this looks like it's a potential function, or this looks like it's a conservative vector field, that means we can find a potential function. So let's take a shot of finding a potential function, and that means that these would have come from a little f function whose derivative with respect to x is 4x cubed y to the fourth. And so we take the antiderivative of that with respect to x, and that should give us our potential function. Now, antiderivative with respect to x is going to give us a 4 or an x to the fourth divided by 4, and you multiply that times 4. That'll give you 0. So x to the fourth, y to the fourth is constant. And some constant, let's call it g, constant with respect to y. And similarly, if we integrate the second function for x to the fourth y cubed with respect to y, we're also going to get the same thing. It looks like we can then identify your potential function as f of x, y equals x to the fourth, y to the fourth. And then if we evaluate this at the start point, and well, before we do that, let's just say that we are computing the line integral. And because this is a potential function for this gradient or conservative field, then we simply find this. We found the potential function. We evaluate this at the endpoint minus the function evaluated at the start point. And the endpoint is 1, 1, so we'll put 1, 1 in there. 1 to the fourth, 1 to the fourth, minus, and then 4, 4, 4 to the fourth, 4 to the fourth. Okay, and so clearly this is bigger, so this is 1 minus, let's see, 4 raised to the fourth power is 256, and we double that, and we get 512, and subtract 1, we'll get negative 511. So it is a negative number. The number itself wasn't important with respect to the question. They're asking if it's positive, negative, or 0. And it is negative, and we were right in our guess hypothesis saying that the tangent vectors are opposite of the other vectors, the vector field. All right, I hope that helps.